Girls, how are you? So the exams are drawing near, and we won't be able to complete the syllabus. It takes a lot of time. Environmental science is a very vast subject. We discussed it earlier. What we are going to do is we will continue with our topics. Meanwhile, I suggest that everyone who has learned and who has not prepared to attend the exam, because until and unless you fail, you won't be able to pass. You have to first burn like a sun if you have to shine like a sun. Do you know who told this? Find out. So today's topic, we will be discussing about atmospheric chemistry. In today's video, we will go in depth to atmospheric chemistry. Atmospheric chemistry majorly deals with the four layers and the gases in it. The gases in it signifies or predicts the kind of pressure and temperature phenomena that goes on in the atmosphere. In our last class, we have discussed about the gases that are present in troposphere, stratosphere, mesosphere, and also thermosphere. In troposphere, last class we have discussed about the gases present in it. They are oxygen, nitrogen, argon, CO2, and H2, carbon dioxide and water. H2O here signifies water vapor. I am not talking about liquid water. In troposphere, H2O, water vapor, forms a major constituent, and it is significant and it is relevant to make water a major constituent of troposphere, because it predicts, it deals with many kinds of stuff in troposphere. So let us see them. In troposphere, these are the gases present there. In strato, the major gases were oxygen, nitrogen, and ozone. And ozone is a guy of a little bit more interest. This guy is responsible for being a protector in stratosphere, which protects us from the harmful ultraviolet radiation of sun. But when this guy comes to troposphere, he becomes a villain, a destroyer that can kill skin cells. We have discussed it in last class. So how does this happen, or how does ozone comes into form, and how does it help us from the UV radiation? Let us see that. Ozone is actually formed when oxygen, dioxygen, reacts with a superoxide radical. When these two guys form together, it forms ozone. This is a reverse reaction, which means it can go either way. When the situations come, situation is suitable, it becomes ozone, and the situation is not suitable, it becomes dioxygen and superoxide radical. So when these two guys react together, it forms ozone. Ozone is stable, but compared to oxygen, dioxygen, it is less stable. So when ozone comes into form, what happens is, in the stratosphere, sun's rays come from sun. When it reaches stratosphere, there forms a particular reaction where ozone becomes oxygen and dioxygen again when it is hit with UV radiation. So when UV radiation hits stratosphere, the ozone there is dissociated into oxygen and dioxygen. As a result of this reaction, the UV radiation of sun gets used up and doesn't reach troposphere where we are present. There are three kinds of UV radiations. They are UVA, UVB and UVC. You might have seen from the advertisements of fairness creams of how the fairness cream like Fair and Lovely helps us or protects us from the harmful ultraviolet radiation. It is how they do their business. Actually, if our ozone guy is not present in the stratosphere, these guys are capable of UV radiation, especially this guy is capable of burning our skin. It will just burn our skin and we will run like hell when if this guy hits our skin. It will burn our skin. This guy is that much strong. What happens is in stratosphere, UV radiation when it comes, UVC radiation is absorbed by ozone radical and forms ozone molecule and forms oxygen, dioxygen and superoxide radical. And because of this reaction, UVC doesn't reach the surface of the earth where we are there, and thereby protects our troposphere from harmful UVC radiation. It also helps ozone also helps us from UVB radiation also. This is also harmful, but not as harmful as compared to UVC. So the most notorious, the most harmful among the three radiations are UVC radiation, which will mostly get used up by ozone, and UVB is also used by ozone to a certain extent, so that majority of UVB doesn't reach the Earth's surface, troposphere, where we are living. So to conclude, UVC gets used up fully in this reaction and UVB partially or majority of UVB gets used up in this reaction. So how can we differentiate between UVA, UVB and UVC? Sun's radiation, that is light, includes an idea called electromagnetic radiation. So electromagnetic radiation, sun's rays has electromagnetic radiation. Sun's light is formed of electromagnetic radiation. In this, our concern here is related to UV, ultraviolet radiation, which spans from 400 to somewhere to 200 nanometer. Sorry, UV ultraviolet radiation is our concern here. So among EMR, that is electromagnetic radiation, ultraviolet radiation is a particular concern when we take atmospheric chemistry into concern. So ultraviolet radiation is somewhere from 400 to 200 nanometer. So among these, UVA forms ultraviolet radiation from 400 to 320 nanometer. This is UVA, and this guy is not harmful. This reaches the troposphere. UVB is forms from 320 to 280 or 290 nanometer. So we can take 290. Okay. So UVB radiation is the radiation between 320 nanometer and 290 nanometer. And UVC is the radiation that is below 290 nanometer. This guy can burn the skin. This guy can burn everyone in its way. This guy causes partial problems, and if we are exposed to UVB for larger period of time, UVB can cause serious harmful effects. So, and UVA is not harmful at all. So, when you see this kind of advertisements, they are talking about UVB. They are actually talking about UVB. They are actually talking about UVB. Okay. So, 320 to 290 nanometer UVB. However, no cream can help you if ozone is not present in our stratosphere, because this guy is responsible for helping us or protecting us from harmful UVC radiation, which forms 0.5% of sun's rays, and majority of UVB radiation, which forms 1.5% of sun's rays. So these are the aspects related to stratospheric chemistry. In another aspect related to UVC is, another aspect related to ozone is that ozone has been seriously hampered by chlorofluorocarbons, which is used in our refrigerators. So, according to Montreal Protocol, all CFCs were banned and aimed to be wiped out. We will discuss about Montreal Protocol and CFCs in our next video. So these are the aspects related to ozone. So until our next video, bye.